So look, everywhere I go, people are posting this picture of this viral riddle, and it drives me crazy that I've seen it so much, yet it seems like nobody can figure out how to solve this. So in this video, I'm going to show you how I solved it. So this is a spoiler alert. If you want to attempt to solve this on your own, maybe you haven't seen this puzzle, pause the video now, try and solve it, put your answer down in the comments of this video, then unpause the video and see how you did. All right, so this is confusing because your brain sort of makes a lot of assumptions right away. Eventually, you will choose to redirect attention in different areas of the puzzle. They give you some hints down here by saying the answer isn't 19 or 26, so a lot of people come up with those answers first and then get stumped, and then you have to start figuring out why you came up with the answer you did. So here's what I'm going to do. I'm going to go through this real quick and show you how to get the answer. So you've got these shapes, that plus that equals 45. Well, if you take 45, divide it by 3, you get 15 out of each one of those. So now you got to figure out why each one of those has a value of 15. We'll talk about that here in a second. Then you've got this one that's a 15, and 15 plus these two banana bunches equals 23. So if you subtract 15 from 23, you get 8, so there are two of those that equal 8, so if you divide that, assuming they're equal, by 2, then each one of these are worth 4. So now we know, let me draw here. So we know that that's worth 15. We know that this one is equal to 4. And then now we've got the new clock. So 4 plus something equals 10. If you take 10, subtract the 4 that we know that is, that leaves you with 6 here. 6, assuming these are the same, you divide that by 2. Each one of these is equal to 3. All right? So here's where people start to run into mistakes, right? They say, okay, well, the clock is 3, so that must be 3. The bananas are 4, so that must be 4. And 4, and we know the shapey thing is 15. And then so we add all those up. 3 plus 4 is what? 7, 8, 9, 10, 11. 11 plus 15 is what? 26. Oh, no, we know that's not the answer. So that can't be it. All right, so let's rethink this now. We know we can scratch out that. So something is different here. So what you need to look at now is look at the shapes themselves. Are they identical? And if you look at this square inside a pentagon, inside a 1, 2, 3, 4, 5, 6, a hexagon, you can tell that, oh wait, we're missing something in here. So what is going to be different about this? Well, let me just help you out here. We know that each one of these equals 15, so let's count sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Boom. So this one doesn't have all 15 of those sides. So how many sides does it have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This one's only worth 11. So does that help us out? Well, we'll see. Let's go ahead and do the same exercise with the bananas. These bananas are worth 4, but if you look, there's 1, 2, 3, 4 bananas. If you look down here, there's only 3 bananas, not 4. So let's assume that these are each worth 3, okay, because there's only 3 bananas in them. Let's look at the clock. This clock is worth 3, but if you look at the time, it's set at 3 o'clock. This time is only set at 2 o'clock. Let's assume that this time is worth 2. All right, so we've got something different here. We've got this 2 plus 3 plus 3, 11, right? So 2 plus 3 is 5, plus 3 is 8, plus 11 is 19. Oh, wait, 19 is one of the ones it can't be. We know it can't be that. So what are we doing wrong here? Well, now we need to pay a little bit of attention to detail. I will tell you this was right. 2 plus 3 plus 3 plus 11, except for that last plus part, because if you look at the operators, we have a plus, and a, what is that? Not a plus. That is a multiplication. So now if we look carefully at this, it's 2 plus 3 plus 3 times 11. All right, so now, if you just run this straight, 2 plus 3, 5, 6, 7, 8 times 11 would be 88. Is that right? No. Here's why. We have order of operations. In math, there's always an order of operations. You do your multiplication first. So 3 times 11 would be first. Then you can add in your 2 and your 3. So 3 times 11 is 33 plus 3 plus 2. 33, 34, 35, 36, 37, 38. My guess is that 38 is the answer. And that's what I will maintain. Now, whether or not that's true, I don't know. But I will say that's the solution I have come up with. You tell me if you disagree or not. Thanks for watching, guys. I'll catch you on the next one.